Hi, in this video I'm going to talk about how can we compress data using principal component analysis. So let's imagine that we have a data capital X where each data point is represented by two features and there is a linear relationship between these two features. So we can actually compress this data using principal component analysis as long as there is a linear relationship between these two features. But if the features are completely independent of each other, then it would not actually make sense to data compression using PCA. Okay, so to compress this data in this context would be to represent each of these data point using a single feature, rather than two feature. Okay, so we can actually do it by projecting this data along its first principal component, and the first principal component of capital X would be the eigenvector corresponding to the largest eigenvalue of the covariance matrix. So this will give you the covariance matrix of X of the data, and this is a 2x2 matrix, which means that it will have two eigenvector and two eigenvalues. Okay, so this is the largest eigenvalue, which means that the second column of the eigenvector matrix would be the eigenvector corresponding to the largest eigenvalue, which would be our first principal component. Okay, so and if you want to project this project this data along its first principal component, you have to multiply it with the first principal component. So this is what we are doing here. So this will give you like the compressed data. Okay, so let's imagine that you have sent this compressed data to your friend, which would be much easier because this compressed data has reduced dimensionalities, right? Because as you can see that here each data point is represented by a single feature. Okay, so your friend from the other end may want to reconstruct the original data from the compressed data, and actually he can do it by multiplying the compressed data with the transpose of the first principal component that we obtained earlier. So this will roughly give you an approximation of the original data. And if we plot the reconstructed data and the original data side by side with two different colors, we can see that the reconstructed data is approximating the original data. But like I said before, reconstructing or compressing data and then reconstructing the original data would be possible only if there is a linear relationship between these two features. Okay, I mean between the features of each of the data point. So let's imagine that there is no linear relationship between the two features. Okay, so we can actually do it by getting rid of this linear relationship, and let's see if it still makes sense to compress this data and then reconstruct the data. So yeah, as you can see, like this is the reconstructed data, and these are the original data points, and there is hardly any similarities between them. So in this case, it actually doesn't make sense to compress this data using the principal component analysis.